It is so important that product designers and brands understand how the polymers that they choose for their medical devices will perform in the real world, particularly when they will be exposed to multiple disinfectants and other chemicals. To help differentiate plastic performance when combined with frequent disinfection, Eastman developed a 4-step test method using plastic flex bars on a strain jig, followed by a reverse side impact test. But it is also important to see how that translates into actual performance in the field. That is why we took our testing a step further with a housing drop test. This test can be used alongside the 4-step method to understand how a well-designed device will respond to impact after being disinfected.
As a mechanical engineer at Eastman, I regularly advise customers on part and tooling designs with copolyester resins. When I was asked to design a medical device housing for this drop test, I started off by designing the top and bottom with uniform wall thickness and gradual transitions, all while avoiding any sharp corners to help minimize stress.
The materials we tested are commonly used in electronic medical device housing and hardware. We assembled each molded part with 6 screws using a fixed torque. Then the devices were submerged in Virex TB, a commonly used hospital disinfectant, for approximately 2 hours. To replicate use in a hospital environment, where devices are moved, dropped, and bumped after being disinfected, we dropped each device multiple times from 3 feet and visually inspected for cracks and breakage. The result of the housing drop test matches very closely with the result we obtained using our previous 4-step test. In some polymers, yellowing, chalking, stickiness, and cracking were seen in high-stress areas, such as around the screws. After exposure to the disinfectant, the top and the bottom, in parts made with polycarbonate ABS, broke away at the screw bosses after exposure to Virex TB. After 3-foot drop, parts made with PCPBT and Triton both appears to have no damage at first glance. However, if you look closely at the high-stress area, such as the screw bosses, you can see cracks in the part made with PCPBT. However, Triton shows no signs of cracking around the screw bosses.
Choosing plastics based on the best testing and design protocols will lead to more reliable devices that are designed to withstand the demanding healthcare environment.